the sequence, a geometric sequence homework from page 584, we're going to be looking at question 28. And then we have 2/5, a blank, and then we have 8/45, and then we have ... And it's asking you to find the middle term. Do you agree? And it says that it is geometric, and so we're told it's geometric. If it was arithmetic, well, we would be adding a common d to each term. But it's not. It's geometric, so that means that we're going to be looking for r's, right? And what do? Do we add those r's or do we multiply those r's? You multiply them, because if it's geometric, we're going to be multiplying. So the way that we set up our equation here is 2/5 times what? R squared. Good, because there's two of them, is equal to 8/45. Okay? Now, because of the fractions, it might have confused us a little bit, but how do I get rid of, I have to solve this for r. How do I get rid of the 2/5? There's two ways to do it. Which way would you do it? Divide by 2/5. Perfectly to do one way. Anyone think of a different way to get rid of the fraction? Multiply by the reciprocal. Good, Oshimi, okay? This is exactly what we're going to do. So we can do either way. Which way would you probably have done it? You probably would have divided? Okay, that's okay. Just make sure that you realize when you do that, we're talking about a complex fraction here, okay? So we are going to get r squared equals something, okay? So in your calculator, if you want to deal with this complex fraction, we're going to have to worry about putting it in. So we can alpha y equals, and we can plug in another alpha y equals. So we're going to get 8/45, and then we'll do another alpha y equals, divided by 2/5, and we get 4/9. Okay? Once we get 4/9, how do I go ahead and solve for r? How do I continue to solve for r? Daniel? You're doing it. You're the square root. Exactly. So I'm going to take the square root of both sides. Okay, so r is going to equal, when I take the square root of both sides, I have to put a plus or a minus in there. R could be positive or r could be negative. So plus or minus. And then because it's a fraction, what's the square root of 4? 2. What's the square root of 9? 3. But that plus or minus is that r could be positive or negative. Okay? Meaning that I could, because remember how we talked about last time in a geometric sequence that sometimes the signs can alternate. It can go from positive to negative to positive to negative. And if that happens, it's because the r is negative. So there's two possible answers. I think you were asked to find the missing term, right? Not just the r. So if I want to find the missing term, I would take 2/5, and I'm going to multiply it times 2/3. So we'll go ahead and do our alpha y equals 2/5 times 2/3. And we know how to multiply the numerators and the denominators, and we get 4/15. So the missing term here is 4/15. Why do I put a plus or a minus? Well, it could be positive or it could be negative. Okay, that's really the only thing you have to worry about. Daniel? Because yeah, I probably would, not a lot, but maybe like a half a point or a point or something like that. Okay, I'm not sure what the book way was, but what, under the square root? Okay. But did you get the plus or minus? Yeah, that's fine. There's definitely always going to be more than one approach. So if you find something that works for you, awesome. Okay, let's see, any questions on this one? All right, let's look at question 34 then, okay? So in question 34, what is it asking you to do here? It says write a formula. Okay, well, this one should have been pretty straightforward. Let's see, so a sub 1 is equal to 7, and r is equal to 1. So it tells us that we're looking for a geometric sequence. We have the first term in the r, which is all that you need. On your formula sheet, isn't that the formula for a geometric sequence? You need your formula sheets out today, by the way. So if you don't have them out, you need them, because we're going to be looking at more of those formulas on the formula sheet today. The S formulas for summation. So we're going to look at those.
Yeah, I need to learn how to do this stuff because I'm lost.
Then you need to get it out, and let's look at it. So we're going to replace in this formula here, the a sub 1 with the 7, and we're going to replace a 1 with the r. Okay? So my formula is going to be 7 times 1 to the n minus 1. Questions? Is it 0.1? Let me double check. I believe you. No, it's actually 1. It's 1. Maybe you just copied it down wrong. It's actually positive, just plain old 1. Now here's a question I have for you, and it's very, very important. Look at this. Tell me if I can do this. Hang on. Let everybody have a chance. April says no, so let's think about what you think. Hang on. Can I simplify what's on the left-hand side to get what's on the right-hand side? So we all agree it's a no. You sure? Okay. So you can't do that. Someone needs to explain why, though. Okay. What if this was also a 7? Could I make this a 49? What do you mean by different? Go ahead, Christian. One has an exponent and one does not. So the most common mistake that I see with stuff like this is people want to multiply those two numbers together. And if you actually look at your formula sheet, underneath geometric, they don't even have on the formula sheet that dot, do they? Do you see that? They don't have a dot. I put the dot there to kind of remind ourselves that we cannot multiply those things together, okay? But sometimes you will see it just written like this. And you have to remember, you can't multiply the 7 and the 1, okay? You can't. One has an exponent, one does not. We okay with that? So that's your formula. Now it just says to generate the first 5 terms. What do they mean by generate the first 5 terms? What does that mean? So we're going to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Where am I going to start? Which is what number? 7. And then I'm going to multiply by what? Multiply by 1. So what do you notice?
It's going to be the same.
It's the same number every time. Because when you multiply by 1, it doesn't change, right? So it's just 7 times 7 times 7. It's just, 7 times 1 is 7. So it's just, that's the sequence. It's kind of a goofy sequence, but it is. All right, the last one that we wanted to look at was 44. Okay? So let's look at that one. All right, 44 says find the missing terms. Ooh. And as Christian pointed out, this is one that's going down, right? Because it starts out at 972. There's 3 terms, and it ends up as a 12. And r will be a fraction or a decimal because it's smaller than 1. I agree. Since we're going down, that makes perfect sense. How many r's am I going to need to multiply to get to 12? 1, 2, 3, 4. To get from the first one to the second one, you have to multiply. So if there's 3 blanks, you're going to multiply by 4 r's. Think about this one back here that we did a second ago. There was 1 blank, and we multiplied by 2 r's. Okay? So there's going to be 4 r's. So we're going to start out with 972. We're going to multiply by r to the 4th, and it's going to equal 12. How do I solve for r? Divide by 972, and then I'm going to do what? Well, I leave it as a fraction. It doesn't really matter. But then what? How do I get r by itself? 4th root. Do you remember how to do that on the calculator?
Yeah.
What do you hit first? The number 4 first. Then you go where? Math. Option 5. Good. 4th root of, and I'm just going to type it in as a fraction, 972 divided by I'm sorry, wrong way, 12 divided by 972. I don't know if it will do a fraction under a square root. Try it. Try it, Tim. Just let me know. I get some, I go to math. It does?
1/3.
Okay, that's fine. And so 1/3 is your answer. Okay. Well, maybe, okay, it actually could have been plus or minus, I believe. Let me see which one. Yep. Because just like in this problem, where we did the plus or minus here because we took the square root of both sides, if your root that you're taking is even, remember how we talked about that? Even 2, 4, 6, 8, we have to put the plus or minus there. So in this case, is this an even number that we're taking the root of? Right? So it's an even number, 4. So therefore, we have to put a plus or minus. Okay? So it's asking you for what the numbers are. So we're going to have two sets of numbers. Okay? The first set is going to be the positive set, and the second set will be the negative set. So 972 times 1/3 is 324. And then we'll multiply it times 1/3 again. And I get 108. We'll multiply it times 1/3 again. And I get 36. Because there's 4 of them. Okay? And so that's one possible set of answers. Since we're talking about R, the signs can alternate between positive and negative. So the other possible answer is that I could just say, oh, it could be, this could be positive, this one could be negative or positive, positive, negative, or positive, positive. The next one would have been positive or negative. They alternate, okay? So that would be the possible answers in that case. Okay? Hey, Bone. Anytime it's geometric, there's an R involved, okay? It is possible that every other term could be negative, okay? Because when you multiply a negative times a negative, you get a positive. So if R was negative, that means the signs are going to alternate. If your common ratio is negative, the signs are going to go back and forth, okay? If it's positive, it just stays all positive, okay? All right, go ahead and put your homework away for me, but keep your formula sheet out because we are going to talk about arithmetic series today. And we have to first decide what a series is versus a sequence, okay? A sequence is just a string of numbers with commas in between them, like you see in purple there, 4, 8, 12, 16, 20. The series is the sum of a sequence. Okay? So notice what you see differently with the series. I see a bunch of plus signs. So that's the only difference between a sequence and a series is just the sum of it. We're going to add the sequence together. Okay? That's why in your formula sheet, if you look at the formulas underneath the sequences, you have the A sub n's were the explicit and recursive sequences formulas. And then the S's stand for sum. Okay? So if it's a series, you're dealing with the S's. If it's a sequence, you're dealing with the A's. On your formula sheet anyway. Do you have your homework? Can I see it, please?
Sum it up,
all right, so we're going to be looking at the sum of sequences now. So we're talking about, there's two different kinds of series. There is what we call a finite series, which means it ends. So this particular series that I have drawn up here is a finite series because it stops at 20. It has an end, and we can sum that up. There's something called an infinite series as well that we're not going to get to until next class. But a series that goes on forever and ever and ever and ever, that's called an infinite series. So if you look at questions 3, 4, and 5 down here, which one would be a finite and which one would be an infinite? Looking at number 3, finite or infinite? Number 3. Does it have an end point or does it go on forever?
It goes on forever.
Doesn't have the dot, dot, dot. So it's a finite series because it ends at 40.
So,
If it has the dot, dot, dot afterwards, that means that it's an infinite series and it goes on forever. Right, it goes on to infinity. That's exactly what it means. Okay? That's exactly what it means. And there are some cases where an infinite series can be summed. We can find an actual answer. Kind of like up here, the sum of that finite series has an answer. It's 60. Okay? Some infinite series have a finite one, or some infinite series have an answer, or a sum. Most do not, but some do. If it's written this way, yes. Well, we're going to talk about another way to write a series. Another way to write a series is with this big symbol. And if I had an infinite up here, that would mean the same thing as the dot, dot, dot. Okay? That dot, dot, dot means this. Same thing. Okay? We'll talk about that when we get to it. All right, so we're going to stick with just finite series today. Okay? Just finite. And we're going to have two different kinds. What are my two different kinds of sequences that I had? Arithmetic and geometric. And they're the same kinds with series as well. We're going to start with a finite arithmetic series. And you have a formula on your formula sheet, so let's look for it. Arithmetic series, we have two formulas actually. You have this one, which I've highlighted here. I'll write it a little bit bigger so you guys can see it. But the sum should look like this. And I think that it's written a little bit differently on your formula sheet. I believe they have the 1/2. Do they? Oh, no, they don't. They have it exactly like that. Good. So it's the sum is the number of terms. That's what n stands for, divided by 2. And then you add your first term, and you add your last term. So let me write what that is. This is the first term.
why is it n and not 2?
This is the last term. This is just a general formula, honey. And this is the number of terms. Okay? And this stands for the sum. This is the sum of a finite arithmetic sequence or series. Just put that right there for me. Okay? And again, you have the formula on your formula sheet. I just want to make sure you know what each of the pieces stand for. Okay? S does mean sum. Do you have your homework, Will? Do you have your homework?
Yeah.
Can I see it, please, if you have it? Let me see your homework as well. So this is an example of a finite arithmetic series. First of all, I don't even have to tell you that it's arithmetic. You should be able to decide that for yourself. How would I check? Nope, because I could have a geometric with the addition. Yes, you could. We're going to look at that in a minute. What makes it arithmetic? The plus signs don't make it arithmetic. The plus signs make it a series.
The plus 5 is arithmetic.
Kimberly? Not divide. Arithmetic. Oh, wait, go ahead. Finish your thought. Okay, so if I was checking for geometric, I would divide the numbers to see if I get the same thing. And so I would take 9 divided by 4, 14 divided by 9, 19 divided by 14. I don't get the same number if I do that. So how would I check if it's arithmetic? Christian? Right, we're looking for a common difference, and we find that by subtracting. 9 minus 4 is 5. 14 minus 9 is 5. 19 minus 14 is 5. So we found a common difference of 5. So I know it's arithmetic for that reason. Oops. So let's go ahead and write that. D is equal to 5. Okay? So now what we want to do is we want to look at our formula that I just gave you, and I want us to decide what pieces of information. The question is asking, what is the sum? Which means I'm looking for an answer. I'm looking for 316. I'm looking for an actual number, what the sum adds up to be. So if you have your formula, we need to replace in our formula several things. We need to decide what the first term is. We need to decide what the last term is. And we need to decide how many terms there are. So that's the information that we need. So if we're looking here, what is the first and last term? 4 is the first term. And you said the last term was what row? 99. Good. And Christian, you already told us what the common difference was. What's that? Perfect. Why do I care about the D? Because that wasn't something I had to plug in here, was it? Not something I had to find. Okay. Well, I needed the number of terms, right? Well, do I know how many terms there are until I get to 99? I mean, I have this as my first one, the second one, third, fourth, fifth. I don't know. Do you see how there's that gap there? So we need to be able to figure out how many terms there are. So if you actually look at your second formula that you have written under there, there is yet another formula there. Oh, that's not going to help us either because you need n in that one too, don't you? Okay? We're still looking for n. So in order to figure out how to determine how many terms there are, this is the key part. We're going to go ahead and we're going to figure out 99. Okay? The common difference is not 4. Okay? I'm not really looking how they got that. First term. Okay, sorry, that scared me for a minute. I'm like, what are they doing? All right, so that's that. You're right. So what we're going to do is we're going to take the last term, and we're going to subtract the first term from it. Okay, so to get this number, and then we're going to divide by the D, and then add 1. Okay? That's not how I would do it, but that's okay. Can I do it a different way? Can I do it a different way than this? I don't like this way. Because this is like something I have to memorize that I don't really like. I'm going to do it differently. Let's make it easier on ourselves, shall we? Okay? I know it's arithmetic. If I want to use an arithmetic sequence formula, don't I know this one? Don't I know that? If I want to find out what 99 is, what term number it is, can't I just use this? Which means I can say, okay, 99 is 4 plus, I don't know what term number it is, but I'm going to solve for it. Do you see what I did there? A lot easier than I'm not sure what they were trying to do. Okay? So let's use a formula that we have on our formula sheet. A sub 1 just is the first term. That's all that means. I replaced it with a 4. D was 5, so I plugged it in. Daniel. What we're trying to find, that's the number of terms. I don't know that yet, so that's what I'm looking for.
So the n stays like that.
The n, and then we'll solve it. It's the same n. And 99 is the A sub n. That's the last term. We're trying to figure out what term number 99 is. So we're solving for the n.
Oh, so we're trying to figure out how many times we have to add to get.
Yeah, because you need all of these things to be able to find the sum, right? If you look at your sum formula, we needed those 3 things. The A sub 1 and the A sub n were easy to find. You can just look and figure that out. But the n was a little harder. So we had to use a different formula to get there. That's all. Okay? So let's solve this for n. I'm going to go ahead and pause the recording, take my attendance real quick. I want you to distribute the 5 and solve for n. What, baby? You have the answer? Okay, great. Then we'll let everybody else have a chance too, okay? All right, so I'm going to solve for n, and I get 20 when I do that. And then I'm just going to plug in what I know into the formula, okay? I needed to have all 3 of these things in the box. Thank you. I needed to find the n, which I have as 20, the 4, and the 99. So let's plug those 3 numbers into that sum formula and figure out what the actual sum of that series is. So this is 32. Okay, and I don't know how many terms are in there, but I want to find the sum.
You got 5, 5.
Is it arithmetic or geometric?
Hold up, you're going down a number.
I did?
Going up.
Oh, I missed a term. I missed a term, though. He's right. It's not arithmetic. Okay? He's right. That number shouldn't be 16, should it?
But it doesn't add up.
Right. What number should it be? 17, right? So you're exactly right. So let me try again.
I was like, hold up.
You're right.
Y'all always like to be like, oh, good.
But we're still going to have a 32 here. Okay? All right. Should be better. So my question is how do I sum the series? Now is it geometric or arithmetic? Now it's definitely arithmetic. Let's identify this in the sum formula what we need. Remember that we're looking for n over 2, and we're looking for a sub 1 plus a sub n. So what is anything that we know? Give me one thing we know in the formula. In this particular formula. We'll get to the d in a minute. You're right. We need that, but not right now. What do we need? Do we have n? Do we know how many terms there are? Not yet. Do I know a sub 1? What is it? All right, so we're going to plug a 2 in here. Do I know my last term? What is it? Okay. And so all I need to find is the n. Do you agree? And then I can figure it out. So I don't know what term number that is. Because it's pretty close to 17, I could probably add real quick and get to it. But let's practice doing it the long way. Okay? So if I don't know n, I'm going to use the sequence formula to find it, which is the very first formula that you see. Okay, very first one. So I'm going to plug in, what is 32? I don't know what number it is. So I'm solving for n. A sub 1 was 2. Raul, now we need our d. What's d? Okay, so we're going to solve this equation for n, because I need to know what term number that 32 would be. So you guys tell me. Go ahead and solve that equation for n to tell me what term number 32 is. So n is 7, which means I'm going to plug a 7 into my sum formula, and we're going to figure out what the sum of all these numbers added together are. So we can type it in just like you see it if you want. We have 7 over 2 times 2 plus 32. And we should get 119 as my sum. So the sum of the first 7 terms is 119. Okay? That's what we're looking at here. If we did an arithmetic series, and I said, what would an infinite arithmetic series look like?
Early.
Infinite series. What would it look like? There would not be an end. Because if I kept adding 5, because that's our D, and I kept adding 5, it would just keep going. It wouldn't end. Okay? So arithmetic series there's no sum for a finite one. I'm sorry, for an infinite one. They don't have sums. But once we get to the geometrics, they do. All right, any questions on the formulas right now? Again, use the sum formula. And if you're trying to find your n, you use the sequence formula. Okay? All right, we're going to look at summation notation. Okay, and this is the other thing that we're going to need to look at, that thing that Natalia found for us. Okay, and I want us to be able to write it in what we call evaluating summation notation. Okay, so this stuff right here, okay, is what I'm looking at. I want you to tell me what this means. Well, let's start with an easier one before we get to that one. If I look at this particular equation, Okay? I have a summation problem. I do. Okay? I do. I want us to be able to evaluate that. With that, it's called a sigma, by the way. Okay? It's a Greek letter. And there's a lot of Greek letters used in mathematics. And the higher levels you go, the more Greek letters you'll come across. But this is a sigma. It does mean sum. And let me show you what you're going to be summing. Okay? This is a summation for an arithmetic series. That's kind of like the formulas that we found in our homework for arithmetic. Okay? It looks like a line, 2n plus 1. Okay? So how do I do this? Well, I'm going to start by plugging in the number here. Okay? I'm going to start here. I'm going to plug a 1 in for n. And then I'm going to add to it, and I'm going to plug a 2 in for n. And I'm going to add to it, and I'm going to plug a 3 in for n. And I'm going to add to it, and I'm going to plug a 4 in for n. Yeah, I'm running out of room too. And I'm going to stop at 5. Why do you think I'm going to stop at 5? Because that's the top number. Okay? This is the place where we're going to end. Okay? So the notation is we start at the bottom number and we end at the top. And all this means is I'm plugging in these numbers to the formula that's given here, and I'm adding them together. Okay? Luckily for you guys, your graphing calculator will do this very quickly for you. So Natalia showed us where this summation was. Let's find it. Go to Math on your calculator, and we scroll down all the way to where you see option 0, where it says summation. And it actually creates a little sum, and it has different blanks for you to fill in. Okay? We're going to use an X rather than an A. Is that okay with you? It doesn't matter. So get to the place where I'm on my calculator. Math option 0. If you want to. If you want to plug an A in, that's fine. It doesn't really matter. Would you like to keep the A? I'm fine with that. So let's find alpha A. Alpha A equals 1, 2, 5. And then we're going to plug in 2. I should be N. It should be A's, not N's. I apologize, folks. These letters have to be the same. Otherwise, it's not going to work. If I have an N here, I have to have an N here. These two letters have to 100% be the same number. Okay? Otherwise, it doesn't make sense. That was my bad. So let's use, I think I used N's, right? So we'll plug an N in. Alpha N. Just so it looks exactly like I want it to. And then we have 2 alpha n plus 1. Alpha n. Math, option 0. It should be the exact same thing as if I did all what I've written in blue. Okay? And if you hit enter, we're going to get the answer to be 35. So it's kind of like a shortcut. Do you agree? Shortcuts are nice. So summations, the calculator is very helpful. Oh, show me. Did you plug in n equals 1 to 5? Double check how you plugged it in. Use n. Did you get 35? Make sure, oh, show me. Make sure you use an n and an n here. Whatever letters, make sure they're the same, okay? If you didn't have this calculator, like if you're taking your SAT or something like that, then you'd have to do what we did here, what's written in blue. You plug in a 1, add it to plug in a 2, add it, plug a 3, add it, plug a 4, all the way to your ending point. Okay? This is just the long version. I'm going to try it. So let's go. Is that process okay? So let's go back to this original question that I had down here. Okay? I'm asking you now, which one of these sums is that formula? Well, we have to figure out what the sum is, don't we? So it's a little bit different, okay? Because I don't know what term number 268 is, do you? Because of that dot, 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 I don't know what number it ends on. So what do you think I should do? Is it arithmetic or geometric, first of all? Am I adding the same number? Am I multiplying by the same number? It's arithmetic. I'm adding by what? 7. So I'm going to add by 7. So D is 7. Guess what? This number is always your D. So which answer can I cross out already? Okay. I need to figure out the formula. Remember how I told you when we did this that this was a formula for an arithmetic sequence? So let's do that. Let's find the arithmetic sequence that goes with it. Let's figure out that the formula for an arithmetic sequence is this. We know that D is 7. What's the first term? -5. So what's the formula? Let's see. Do you see that? That's the formula, isn't it, that goes to that sequence? So have I already crossed out another? Oh, that's all of them, isn't it? They're all to 12. Do you see that? They're all 7n minus 12. All right, so that sort of helped. It at least let me cross out answer choice D, right? So what's different about all of these? Okay, so can I probably cross that one out? Because that's not where I start in this series. I always start at 1, right? Isn't this the first term, second term, third term, fourth term? Okay, so can't we cross this one out probably too? Let's see what would happen. If I say that this is the first term, second term, third term, fourth term, fifth term, well, we don't know what these are. I need to figure out what term number that is, because isn't that this top number? Do I go to 50 or do I go to 40? How do I figure out the term number for the last one? That's exactly right. 268 is what term number? Let's solve for n. I don't know what term number it is. So add the 12 and divide by 7. So 268 plus 12 divided by 7 is 40. So this is the 40th term, which means that my answer must be B. I want you to find the sum. Tell me what it is. Use your calculator if you want to. Let's practice. Find the sum. Tell me what you're going to do. Go ahead and do that for me. Find it. Find the sum. No, it's for you to work on right now. Okay. What is the sum? I don't see anybody with their calculators plugging it in except for Raul. You already did it? Okay. Let's see if everybody else gets the same answer. So again, math option 0. Plug in the formula. Tell me what we get. I'm looking for n equals 1 to 40. And the formula I got was 7n minus 12. And it looks to me like 5,260 is the sum of the first 40 terms. Okay? So, you guys were asking, because we already figured out, we eliminated all the other choices.
But it was left with A and B.
Right, but we figured out it was B because we solved for n and we got 40. We added 12.
Oh, so that's
Uh-huh. Sure. I used this formula. I shouldn't have gotten, it should be 270 or 280, sorry. Thank you. Okay. Okay. All right, so I've given you guys some problems on arithmetic series to work on, okay? Because I said that the last number in my series was 268. So 268 is what term number we solved for n. Once we had the formula, we were able to do that. So if you look at this, I do want you to save I want you to save the word problems. So I want you to save for 5, 16, and 17. We will come back to those. But for now, I just want you to do 1 through 4. And I do want you to do 6 through 15. Now, problem number 6 says to write each arithmetic series in summation notation. That is what we did here. Okay? That means that you're going to have to figure out the formula for each of these on problem 6 and 7. So 6 and 7 are just like this, where you had to find a formula and figure out what term number the last one was. It doesn't ask you to find the sum, it just asks you to write it in this summation notation. Okay? So 6 and 7 are a little bit more difficult. I'm going to pause the recording for a little bit. I want you guys to practice in a couple of minutes. We'll work together if we need to. So your homework is to finish this if you did not finish it in class. If you finish it in class, you don't have any homework. It's kind of nice.